in this parent function, y equals 2 to the x power, the y-intercept is 0, 1, and the asymptote is y equals 0. Okay, so that is for this function. Okay. Okay, so if we play around with Desmos and we add or subtract a number at the end of the graph, like on this one, I'm adding 3. So let's see how that changes the graph. Let's just see. We're going to look at the Desmos graphing calculator. And okay, so this is our k value. So this is when k is 0. If we move k, so if it's plus 3, what's the graph doing? Going up. So you can conclude, if you add 3 to the end, it's a vertical shift up 3 units. Okay, what do you think is going to happen here when we subtract 2? It's going to go down 2 units. Let's see that. So if we're here, k is 0, and we make k a -2, minus 2 at the end. It shifts the graph down 2 units. These are in, yeah. All right, so write down vertical shift down 2 units. Okay, something to also note when you're moving the graph up or down. So here, the asymptote is y equals 0. So when you shift it up or down, that asymptote is going to change to be whatever that k value is. So for example, here, if k is -2, your asymptote is y equals -2. If k is 3, that horizontal line is at y equals 3. So by shifting the graph up or down, that changes your asymptote. So here, the asymptote is going to be y equals 3. And then on this one, it's y equals -2. So just keep that in mind. If you change k, the value at the very end, that's going to shift it up or down, and that's going to change your asymptote. Yeah, that too. Okay, so how does the value of k affect the parent function? It shifts the graph up or down. What else does it do? What did we just determine? So it changes the asymptote. Okay, so if it's a big number at the end, that's going to shift the graph how? Up or down? depending on if it's positive, it's going up. If it's negative, it's going down. Okay, so the next one, let's see. Does changing the value of k change the asymptote? Yes. So it's going to be whatever this k value is. So for this one, it's y equals k, whatever k is. The horizontal asymptote is going to be whatever that k value is. And if you don't see a number, what was it if you didn't see a number there? 0. Okay. So if this is your original in blue, f of x equals 2 to the x power, and then we shift the graph up 3 units, that's what this is telling us to do. What is the new asymptote? Y equals 3. Okay. So the new asymptote, that horizontal line that the graph approaches but never touches, changed to y equals 3. Okay? Next, we're going to look at if we add or subtract something with the x. The first thing I'm going to say, if it's with the x, it's opposite of what you would think. Okay? So if it's plus 3, plus 5, you're going to the left. If it's minus, you're going to the right. So it's opposite. So what this value, this h value does, it's going to move the graph left or right. And I want to show you that. Okay. So if our original function is f of x equals 2, let's graph that. Okay. So f of x equals 2 to the x power. There's your basic function. Now, if we change something, if we add something with the x, what's the first example say? Plus 3. So if we do 2 raised to the x power, but we do x plus 3, do you see that going from green to purple, the graph shifted to the left 3 units? So if you add with the x, you're going to the left. Okay, and then if you subtract, let's say we're subtracting 2 here, it's going to go to the right 2 units. Green is still your parent function. If we subtract 2, we're going to the right 2. Okay. So plus 3, the graph shifted left 3. Okay. And then minus 2 was right 2 units. So how does the value of h affect the parent function? It's going to be a horizontal shift left or right. So question, does changing the value of h, if you shift it left or right, does that change the asymptote?
No.
No. Okay. So now if we change the y-intercept, if we change the a value, so if you just think about it, if a is 1 and then you make it 3, you're pulling the graph up kind of. But it's not a shift up, it's going to be a stretch. So if a is bigger than 1, if a is bigger than 1, it's going to be a stretch. Think about a rubber band. When you pull it, it gets skinnier. You're stretching it. So if our basic function, our parent function, again, is 2 to the x, like this one, and then we go and we put in, what was it? A 3 in front of it. We multiply by 3. Do you see how it kind of stretched it? It pulled it up a little? It didn't shift the entire, like, the asymptote is still the same, but you're stretching it. So we're going from a y-intercept of 1 to a y-intercept of 3. That is called a vertical stretch. Okay. And on this one, it's a vertical stretch by a factor of 3. Okay, so if a is greater than 1, it's a vertical stretch by whatever that is. If a is between 0 and 1, if it's a fraction, it's going to be a vertical shrink. Okay, so let's look at and see what that looks like. If instead of a 3, let's do 1/2. Times 2 to the x power. Okay. So if we started out at green, if we multiply by 3, that stretches it, that pulls it up like a rubber band. And then if we make it 1/2, so we're looking at the green, and then we make it 1/2, that's the black line. You can click on it. It kind of shrinks it down, it kind of smushes it. Think of like a trash compactor, smushes, shrink. Okay. So 1/2, that's going to be a vertical shrink by a factor of 1/2. So, question, how does the value of a affect the parent function f of x equals 2 to the x power? That. It's a vertical stretch or vertical shrink.
So, stretch is vertical?
Mm-hmm.
And then they have vertical shrinks.
Okay. It either stretches it, like pulls it, it's getting skinnier, or it shrinks it and it smushes it. Yeah, because A is your y-intercept. So if you don't see anything there, like if we just had y equals 2 to the x power, your y-intercept is 1. But whatever number you have in front, like that is your y-intercept. 1/2 would be your y-intercept here. 3 would be your y-intercept here. So let's put that. Let's put that it changes the y-intercept. So it stretches or shrinks, and it changes the y-intercept. Okay, let's keep going. Okay, so when you put a negative in front, guys, put your phones away. When you put a negative in front, this is going to reflect over the x-axis. So it's gonna, let's just look at that. So if we have our parent function is 2 to the x power, again here, but then we make it negative 2 to the x power. That is a reflection across the x-axis. So we're starting out at green, we make it negative, it's a reflection. Okay. What is the value of a for this function? A is -1. So the y-intercept would be 0, -1. So how does a negative a value affect the parent function? It's a reflection across the x-axis. Okay. So let's review. As with other functions, a stretches or shrinks the graph or reflects it across the x-axis. H controls the horizontal shift. This is H. And then K controls the vertical shift. Okay, so let's do an example. We have 3 things going on here. The negative in front, how does that change the graph? Reflection across the x-axis. Okay. And then it says -4 raised to the x plus 1 power. X plus 1, remember, if it's with the x, it's in the wrong direction. It's opposite of what you would think. So is that left or right? It's going to be left 1. If it's plus, it's left. If it's minus, it's right. So it's plus 1. So we're going to go to the left 1. If you want to be fancy and say it is a horizontal shift, left 1, you can add that to it. And then -5, that was the very first thing we did. Guys, you shouldn't have your headphones in. This is the up and down movement. If it's -5, it's going to be down 5 units. Okay, we're going to stop here because didn't realize this. The next few questions are your homework questions. And that leads me to, for tonight's assignment, remember tomorrow is a digital day. So no, you're going to love me. You are going to love me. I'm still recording for guys at home. So your assignment for tomorrow, you see, we go to modules, and if you go to the weekly planner, it's not completely filled out, but we've got Monday and Tuesday filled out. We go to Tuesday for the assignments. Your assignment for tomorrow is to upload today's homework.
Yes.
Oh my God.
Okay?
Just the 2 questions on the back.
No, it's a separate sheet of paper I haven't given you, but it's not bad.
You can hand out 100 questions.
Okay, let's see where our recorder is and stop recording.